In this video, I'm testing the Gemma 4 E4B IT model, Q5K Quant, running on an AMD Radeon Vega 56 under Ubuntu 22.4 LTS. The whole benchmark was recorded live with OBS, so you're seeing everything in real time. We're looking at token output speed, the reasoning window and thinking mode, CPU and GPU usage, power draw in watts, and temperatures. No edits, no cherry picking, just raw numbers straight from the machine. Now let's talk about the test setup. For the GPU, I'm using an AMD Radeon Vega 56 with a power limit of 145 watts. The CPU is an Intel Core i7 7700 paired with 32 gigabytes of DDR4 RAM. The operating system is Ubuntu 22.4 LTS. We just ran two simple prompts to kick things off. First, we asked the model to introduce itself, and then we asked what it can do. And with just those two basic prompts, we're already hitting around 32 tokens per second. Not bad for a first quick test. Now we switched over to the llama.cpp client. This gives us a much better view of the reasoning window, so we can actually watch the model think. Same as before, we're starting with two simple prompts to keep it fair. Vulkan acceleration is active, by the way, and as you can see, the numbers are pretty much in the same range. Now let's throw something more challenging at it. We asked the model to explain quantum physics, so we can really see how it handles a more complex topic and how the reasoning window behaves under load. On the topic of stability, let's quickly talk about the power limit. We set the Vega 56 to 145 watts, and here's why. Without a power limit, the card actually produces more tokens per second, but after around 40 to 50 seconds, it just crashes. So we set the Vega 56 to 145 watts to keep things stable. At that limit, we get consistent GPU clocks, steady token generation, fewer temperature spikes, and no crashes taking down llama.cpp or the MCP server. The efficiency per watt is better too, and with GGUF models that run a lot of small matrix operations back to back, stability is simply more important than chasing peak performance. At 145 watts, the Vega 56 runs noticeably quieter and delivers solid, consistent performance with no drops. Now we pushed it a little further. We asked two more questions, one about Heisenberg and one about Einstein. The main thing we want to see here is whether the model actually stays in context, or if it starts losing the thread after a longer conversation. Alright, that's a wrap. Gemma 4 answered all the questions and honestly did a pretty good job presenting the information in a clear and structured way. I'm happy with the results, and from what I can tell at first glance, the information looks solid too. key milestones and physics are there, nothing obviously wrong jumping out at me. Overall, a really good result for this kind of setup. Let's not forget, we're running a CPU and GPU from 2017 and 2018 here, and I think that's actually pretty cool. And for the final test, we're going all in. We asked the model to summarize everything, all the physics topics, Heisenberg, Einstein, the whole conversation in chronological order. But here's the fun part. We also told it to generate a proper HTML file using Tailwind, save it as p1.html, and write it directly to disk. This is where we get to properly test our Jarvis MCP server, which provides the file system tools to llama.cpp. So the model doesn't just have to answer the question, it has to reason, structure, format, and actually save a file. And on top of that, this is also our chance to test how well Gemma 4 handles tool use in general. Can it correctly call the right tools, pass the right parameters, and follow through on a multi-step task? Let's see how it handles that. Alright, we're getting close to the end now. You can see it's still processing, and there it is, generation complete. Let's look at the token summary. The entire conversation is now 8105 tokens long, and more importantly, we can see a successful tool call right there. And yes, the file was saved exactly as requested. I love it when everything just works the way it's supposed to. Thumbs up for that. But the real question is, what did it actually generate? Let's take a look at the result. Alright, let's open the HTML file that Gemma 4 generated. And just to make this clear one more time, everything you're seeing here is running completely offline. No cloud, no API, no internet connection, just local hardware. If you want to know more about the exact setup, check the description below. And there we have it. This is the result. And I have to say, I'm genuinely impressed. Good job, Gemma 4. It didn't even take that long either, which is a nice bonus. Tailwind is there exactly as requested. The content is structured chronologically, just like we asked. And visually, it looks really clean too. The effects, the layout, the overall presentation, all solid. Test passed. Thanks for watching, and I'll see you in the next one. If you find this useful, hit the like button and subscribe for more Linux and local AI content.